Now we're going to do section 4.2 on area. Area, we're going to go over a couple of little things and bring it together at the end. The first one is sigma. So sigma, which is the Greek letter sigma, which looks like a big funky E, means summation. We're going to be adding up many terms. The variable we use is either I, J, or K. It starts at any number, let's say 2, and goes to 4. So 2 is your lower bound, 4 is your upper bound of some term. So let's say we did K squared. What that would mean is the number on the bottom, the lower bound, that is what we start K at. We increase K by 1 until we get to the term on top. So, we're going to start off with K is 2. So we're going to get 2 squared, increase K by 1, we get 3 squared. Increase K again by 1, I get 4 squared. And that is what my summation will be. But we're going to want to evaluate this. So we're going to want to add these up. Well, 2 squared is 4, 3 squared is 9, 4 squared is 16. When we add these up, we get 10, 20, 29. And that is the summation. We can do one more of these, show you how nice they are. And this should be review from pre-calc. The summation, I don't know why it's not writing, ink pen. The summation, K starting at 2 and going to 5, of K times K plus 2. So just to separate the problems. All right, so that means we're going to start when K is 2. So 2 times 2 plus 2. Increase K by 1. 3 times 3 plus 2. Plus 4 times 4 plus 2. Plus 5 times 5 plus 2. Once you've reached the number on the top, you are done. So the number up top, your upper bound, is not how many terms there are. It is what term you stop at. So we still need to evaluate this. So this is going to give us 2 times 4. Plus 3 times 5, plus 4 times 6, plus 5 times 7. Simplify again. We get 8 plus 15 plus 24 plus 35. And when we add all of that up, we get a total of 82. So that's what summations are. The reason we need to know about summations is we are going to be finding the area between a curve and the x-axis. So if we just draw a curve like such, and I want to know the area between x equals a and x equals b, it is very difficult to find that exact area as is. So what some people have done to get an approximation of that is to make it into rectangles. And we want to add up the area of each individual rectangle. Well, each rectangle is going to not be exact either, because it's not going to go all the way to the top, or it may have too much information depending on where you top off your rectangles. So we need to know how to do that. Also, be aware, this is where our calculus and our limits is going to come in. As the number of rectangles between A and B grow, you're going to get a better and better approximation. So the exact area between the function, the x-axis from x equals A to x equals B, is going to be given by a limit. And it's going to be the limit as the number of rectangles goes to infinity. So we need to know how to find limits as x goes to infinity. So that's what we're going to do now. All right, so we're going to want to find the limit as x goes to infinity of 1 over n squared times n plus 1 all over 2. All right, the first thing you're going to want to do in order to solve these or evaluate these is get your constants out front of your formula and all of your variables inside your formula. What I mean by this is the limit as x goes to infinity, and I apologize, that should be n, all of your variables should match. So let me just fix this. And these should be n's because it should all match. So as n goes to infinity, it's the number of rectangles. So I'm going to put my constants out front, my 1/2 out front, then n times n plus 1 all over n squared. So what I did was I switched my two denominators. So the constants, the 1 and the 2, are out front of my formula, and all of my n's are inside my formula. After I do that, I want to get rid of my parentheses. So I get the limit as n goes to infinity of 1 over 2 times n squared plus n all over n squared. All right, now that my parentheses are gone, I'm going to break it up to smaller fractions. So I'm going to get the limit as n goes to infinity of 1/2 times n squared over n squared plus n over n squared. And the reason that's nice is I now get the limit as n goes to infinity of 1/2 times 1 plus 1 over n. N squared over n squared is just 1. All right. So now, because n is going to infinity, any fractions that I still have once they are reduced that still have an infinity in the denominator, this whole piece goes to 0 because it becomes 1 over 1, then 1 over 10, then 1 over 100, then 1 over 1,000. So as that denominator continues to grow, the entire value goes to 0. So this then becomes the limit of 1/2 of 1 plus 1 over n, just to repeat it. Oh, I apologize. The limit of 1/2 times 1 plus 1 over n. Hold on. It's not letting me do this. I don't know why. I will continue to try. There we go. Oh, I had it. We're going to go back up and find it. We're going to leave it like that. So that's going to then become just 1/2 1 plus 0. Because the limit as n goes to infinity. So as this denominator goes to infinity, the value of this whole fraction goes to 0. Well, this becomes 1/2 times 1 equals 1/2. So that is the full answer I'm looking for. All right, so let's do one more. Let me get down to a fresh sheet of paper. All right, let's do the limit as n goes to infinity of 81 over n to the 4th times n squared times n plus 1 squared all over 4. All right, so we're going to do what we did before. Bring your numbers in front. So I'm going to get the limit as n goes to infinity of 81 over 4 times n squared times n plus 1 squared all over n to the 4th. All right, then I want to get rid of my parentheses. This is going to be a two-step process. So I get the limit as n goes to infinity of 81/4 times n squared plus 2n plus 1 all over n to the 4th. All right, now I need to distribute you can either distribute the n squared, which is what I'm going to do, or you can get rid of 2n from both the top and the bottom. So I'm going to get the limit as n goes to infinity of 81/4 times n to the 4th plus 2n cubed plus n squared all over n to the 4th. Now that I've gotten rid of all of my parentheses, I can break it into smaller fractions. So I get the limit as n goes to infinity of 81/4 times 1 plus 2 over n plus 1 over n squared. Because the two smaller fractions both still have n in the denominator, it's 81/4 times 1 plus 0 plus 0, which then becomes 81/4, and that's my answer.